Greetings YouTube. Today let's talk about the universe. The universe comprises everything that physically exists, the entirety of space and time, all forms of matter and energy, and the physical laws and constants that govern them. However, the term universe may be used in slightly different contextual senses, denoting such concepts as the cosmos, the world, or nature. Current interpretations of astronomical observations indicate that the age of the universe is 13.73, 0.12 billion years, and that the diameter of the observable universe is at least 93 billion light years, or 8.80 x 1026 meters. It may seem impossible that two galaxies on opposite sides can be separated by 93 billion light years after only 13 billion years, since special relativity states that matter cannot be accelerated to exceed the speed of light in a localized region of spacetime. However, according to general relativity, space can expand with no intrinsic limit on its rate. Thus, two galaxies can separate more quickly than the speed of light if the space between them grows. It is uncertain whether the size of the universe is finite or infinite. According to the prevailing scientific model of the universe, known as the Big Bang, the universe expanded from an extremely hot dense phase called the Planck epoch, in which all the matter and energy of the observable universe was concentrated. Since the Planck epoch, the universe has been expanding to its present form, possibly with a brief period, less than 1032 seconds, of cosmic inflation. Several independent experimental measurements support this theoretical expansion, and, more generally, the Big Bang theory. Recent observations indicate that this expansion is accelerating because of the dark energy, and that most of the matter and energy in the universe is fundamentally different from that observed on Earth, and not directly observable. The imprecision of current observations has hindered predictions of the ultimate fate of the universe. Experiments and observations suggest that the universe has been governed by the same physical laws and constants throughout its extent and history. The dominant force at cosmological distances is gravity, and general relativity is currently the most accurate theory of gravitation. The remaining three fundamental forces and all the known particles on which they act are described by the Standard Model. The universe has at least three dimensions of space, and one of time, although extremely small additional dimensions cannot be ruled out experimentally. Spacetime appears to be smooth and simply connected, and space has very small mean curvature, so that Euclidean geometry is accurate on the average throughout the universe. Conversely, on a quantum scale, spacetime is highly turbulent. The word universe is usually defined as encompassing everything. However, using an alternate definition, some have speculated that this universe is just one of many disconnected universes, which are collectively denoted as the multiverse. For example, in bubble universe theory, there are an infinite variety of universes, each with different physical constants. Similarly, in the many worlds hypothesis, new universes are spawned with every quantum measurement. These universes are usually thought to be completely disconnected from our own, and therefore impossible to detect experimentally.